Okay, well, I think we've got everyone who's going to join, who's come with us today. So thank you very much for the opportunity to speak to you today. My name is Aaron Patterson. I'm the Asia Pacific Chief Technology Officer and Principal Engineer for Dell Technologies. So I have a couple of roles inside the organization. One is to work with our largest, most strategic customers and partners, such as yourselves, to help understand the challenges that they're undertaking from a business perspective, help them plan for what that future kind of looks like, teach them about the emerging technologies that we're creating and how that can be leveraged to create business value, but also to listen to the challenges and how they're solving those today. I have a role in our office of the CTO, driving the research and development for the technologies that we'll see in the next 3 to 5 to 10 years, and your feedback about what's working well, what's not working so well, what areas you're still having challenges with, can feed directly back into that process and make sure that we're developing capability that can help you to solve those kind of challenges. Usually I spend sort of 2 or 3 weeks a month traveling, meeting customers everywhere from India and Pakistan through to South Korea and Japan, through the Philippines, Malaysia, Singapore, and of course Australia and New Zealand. But during this current environment, I'm at home in New Zealand, so I get to stay on terra firma for some time, and I'm definitely enjoying the opportunity to keep back in touch with my colleagues in this part of the world. Now, speaking of the current kind of environment, we are seeing a change in the priorities and the strategies that our customers are undertaking. Typically, people are evaluating the impact that we're having on the current environment and how that's going to impact their strategy and plans. We are seeing that many customers, about a third of them, are expecting to have to save costs and to return that money back into the business. For some businesses, this is an existential crisis. They're literally on the verge of figuring out how they keep their business going past this kind of environment. So they're often being tasked with saving 20 or 30% of their existing budget, and they're looking for ways to be able to cut costs and to be able to look at different forms of efficiency in order to be able to achieve those kind of goals. And in fact, of those that are being tasked with saving costs, around about half of them are looking for major changes in their underlying cost base, which kind of shows you how important some of these drivers are. However, there are still a fair few customers, about a quarter of them, who are expecting to increase their spending over this time. For some companies, they're in a situation where they're in a reasonably solid basis and they can afford to invest in order to be able to undertake new competitive pressures. This is the time that they see that it's a good opportunity to be able to go after their competitors and create new elements within their marketplace. And of those customers, most of them are really embracing agility as their core design concept as they kind of move forward. So rather than designing for resiliency or availability, they're understanding that the world is changing rapidly, the competitive environment is changing rapidly, and they need to be agile in order to be able to address those. There are still many customers who don't actually see much changing in the way that they're investing in technology. And what we see for those customers is that they were already very much on a path towards digital transformation. So digital transformation has been the #1 driver throughout organizations for the last 3 years. In Australia and New Zealand, we tend to be a little bit ahead of the global curve. We at Dell Technologies have been running a regular survey of our senior customers to understand where they sit in terms of embracing emerging technologies, investing in those, and using them to create differential business. And in Australia and New Zealand are ahead of the curve in that kind of realm, and really have reached the point where digital channels and interacting with your customers in that way has become a business prerogative. So it's something that we have to do rather than something that's nice to have. And certainly the plans that we had to embrace this over the next 2 to 3 years are being accelerated to make sure that we're driving this. And in fact, 60% of the respondees of the survey we recently did see business as even more strategically reliant on their kind of IT investments than they ever were before. So when customers are looking at digitalization or digital transformation, they're often looking at leveraging these emerging technologies in order to drive that transformation. 3/4 of the executives that we talk to believe that if they don't embrace these, they will be displaced by a competitor in the reasonably near future. So we sort of see that over the 3 to 5 year kind of time frame, that if they're not keeping up with their competitors or leading the way, they need to start thinking about what that means to their business. And almost all kind of IT managers say that emerging technologies are crucial to achieving those kind of goals. So what do we mean when we talk about emerging technologies? One of the key ones which has been of most interest over this particular period is around cybersecurity. Unfortunately, in times of disruption, and as we are moving our personnel away from the traditional office-based environment that we've been working in, moving them towards remote areas, making sure that they can access core applications wherever they might be, it creates new vectors for attack. And unfortunately, that's created an environment where a number of bad actors have tried to take advantage of that to be able to deploy ransomware or other forms of security vulnerabilities to create kind of impacts on our customers. So cybersecurity is certainly one of the prime kind of areas of investments. The other ones that we see a lot of effort on is things like Internet of Things and artificial intelligence, leveraging our ability to collect data very close to the edge of the network where we're interacting directly with consumers of our services, understand what they're using and why they're using it, and then use those machine learning and artificial intelligence models to create new products, new services, new ways of engaging with those consumers to be able to increase their satisfaction with those services, find new ways of kind of driving revenue, and to be able to deploy new capability. We're starting to see the emergence of new consumer interactions through, augmented reality, virtual reality, and more natural language kind of interfaces. Often that comes in the form of chatbots or NLP type workloads, but we're starting to see for some use cases, augmented reality is becoming a preferred method of engaging with customers, especially in a training kind of regime and its training characteristics. The one thing that all of these workloads leverage, though, is significant elements of infrastructure, and often that infrastructure has to be quite close to the consumer that's using it. We're doing a lot of work in retail and healthcare where we're doing machine vision in healthcare scenarios. Sometimes that's wrapped around thermal vision cameras trying to triage people as they come into an emergency department to try to separate the folk that have running temperatures versus the folk that are coming in for kind of other reasons, and create different sort of triage pathways for those. We're also seeing that as a key component of many companies' back to work strategies or back to site strategies, where they're looking at ways of identifying their employees that need to be handled slightly differently, or at least tracking how their temperature and well-being kind of is over time. Those sorts of environments use machine vision, so GPUs that are connected to cameras to collect that visual information and to be able to process it and make real-time decisions on the thing that they're looking at in front of them, on the person that's standing in the queue. That can really only happen close to the edge of the network. You don't have the time and the bandwidth to be able to take that high definition video feed, send it up into a cloud resource, run an algorithm across it, identify people of interest, send those results back to the edge where they need to be acted upon. That really needs to happen very, very close to the edge of the network. Similarly, in other kind of machine vision cases where we're doing fraud prevention and loss prevention in retail environments, we're looking for matching, for instance, products on going through a self-service till, matching what's been scanned with what we can see through the cameras to try to restrict the amount of loss that happens throughout those kind of channels. Those sorts of workloads, again, need to run very close to the edge of the network. But the algorithms that we train in order to be able to identify those things of interest will run in the core environment, where we can dedicate a lot more compute resource to those. We might collect the interesting information throughout the day, send that back into the central core where those algorithms will get retuned overnight and then deployed to the edge of the network, where we can make real-time decisions based on that kind of information. So these emerging technologies are typically driving new capabilities within our customers, either new efficiencies that are creating new opportunities for revenue or additional opportunities to be able to save costs throughout the supply chain and capability. They're almost always based on that data that we are developing. So we're collecting more information about how our consumers are leveraging or using the products and services, and looking for insights within that data and that information, using those insights to create new versions of those products, and then testing them with customers to see if they get better traction, better input, better opportunities for revenue and kind of profit sharing. So all of that data that we're collecting needs to be stored somewhere. It needs to be analyzed. Insights need to be derived and surfaced, need to be integrated into our product development kind of cycle to make sure that the data that we're collecting, the insights that we're generating, are creating real value for our customers along that kind of journey. And that's creating significant pressure on our IT infrastructure partners. So the types of infrastructure tend to be a blend of core kind of capability, which might run in your data center, it might run in a shared cloud kind of environment, but it almost always involves some element of compute that sits very close to those users right down on the edge. And that's a relatively new environment for our customers to start dealing with. We've spent the last decade or so centralizing all of those compute resources, driving new operational paradigms across those to be able to drive the cost out and improve the resiliency and availability of those services. And now we're being asked to stretch those out, make them available at the edge of the network, but still keep the risk low, keep the operational effort and overhead very low, and allow us to be able to control cost of deploying those kind of architectures. And that's really where PowerStore comes in. So we recently released PowerStore, which is a new product in our mid-range storage portfolio. It's been purpose designed from the ground up. And to be honest, we've taken sort of 3 or 4 years to get it into market, drawing upon the best of technology that we've got in other parts of our storage portfolio, and bringing those together into a truly intelligent and modern platform that's designed for these kind of workloads. It's designed to be able to capture data, make that analyzable, surface insights from that, make it very simple to manage, very adaptable and very agile. So we'll run through that in a little bit more detail. So firstly, being data-centric, it's really designed to be able to scale both horizontally and vertically. So this is a multi-node advanced cluster architecture where the first piece that you buy has at least 2 nodes in it, and you can add compute capability on beside that, which acts as a single system that allows you to be able to share resources amongst all of the nodes within that kind of system. That means that you're not going to run out of horsepower within the individual nodes that you start with. You can add new nodes on as you need to add more processing capability or more performance to the cluster, and you can add more capacity in behind any of those that you have spare performance kind of capability. So it really gives you very dynamic capability to tune the system to exactly the workloads you need today, as well as predict how it can grow to meet the workloads of tomorrow. Also, because of that multi-node advanced clustering architecture, it has extremely high levels of availability, 6 nines of availability, which normally you would only see in the very top tier of enterprise class kind of workloads in this kind of space. It's a completely active architecture, so all nodes are active all of the time, processing IOs from the servers that are attached to them, and being able to drive true high performance right the way through the NVMe stack, which sits inside of these. We're also ready when NVMe over fiber starts to get deployed within our customers to be able to drive that performance all the way through the fabric and right to the servers that sit on the end of that. And because of the amount of power we've got built into it, leveraging these modern platforms, we're able to do always-on inline data reduction to achieve extremely high levels of compression and deduplication, which ensures that the data that we're storing takes up as little space as possible, trying to address those customer challenges around reducing the cost to deploy some of these types of architectures into their kind of environments. Now, from an intelligence perspective, we have code processors built into these architectures that do real-time monitoring of the workloads that the PowerStore is running to try to tune it and adapt it to be able to meet those workloads exactly for the needs that they have. So it'll monitor the environment and be able to shift workloads around, dedicate more or less resources to those as and when they need to. One of the really interesting things about this is, given the opportunity to design this from the ground up, we've designed it in a native containerized architecture. So each of the components of the operating system that make up the software components of PowerStore are individual containers that work together across an API-driven architecture inside the PowerStore appliance itself. That means that we can integrate it very quickly and easily into other environments where we've got infrastructure as code or continuous integration deployment type architectures, where we can start to drive the infrastructure directly from within the code. So if you've got an application that needs to scale quickly to be able to handle your users' needs, you can instruct the PowerStore to be able to improve the amount of bandwidth and resources that it's giving to that application, make sure it can scale up to meet that need, and then scale that back down again afterwards when that peak is kind of passed. So it's a completely autonomous method of being able to integrate and make sure that it's delivering upon those kind of application capabilities. And that flexible containerized architecture means that we can deploy this as an appliance, we can deploy it as a virtual appliance, but one of the very interesting things that we can do is what we call apps on. So we can actually run this on top of our VMware ESXi hypervisor, so you can buy a version of the appliance that already has VMware in it, with the PowerStore running as a native workload on that, but it also has the capability to run generic VMware workloads. So where you've got data-centric workloads that are doing a lot of that analysis that could benefit from reducing the latency by not having to take the storage across a network, but actually running directly on the platform itself, you can now host those in the platform, and you can migrate them backwards and forwards as you need to, using the native kind of VMware capability to do that. But it's a very powerful method of both working with data-centric, analytics-centric kind of workloads, but also in those very small edge environments we were discussing, where perhaps you don't have the capability to run dedicated infrastructure for workloads, as well as a dedicated storage platform that handles some of these, high volume, machine vision type workloads. You can now run those on one machine. So you've got some options. If any of you know our VxRail platform, which is hyper-converged, if it's very workload-centric, that's a really good platform for it. If it's more of a data-centric workload with a few applications, then this is a really good way of being able to deploy those. It's been built to be very small, very easy to deploy in edge environments that often aren't built to the same kind of standards as a data center that we would normally kind of use. So it can be deployed into an edge environment that's it's very easy to manage and appropriate for the kind of situation. We also, through our Dell Tech Cloud Platform program, we can use a very flexible consumption method around this. So many customers, as we mentioned at the beginning, are looking for an agile method of consuming infrastructure. And where some of these are not necessarily tailored towards consuming cloud resources, they still want to be able to consume their infrastructure in a way that's cloud-like. So only pay for what they need when they need it, and be able to align that cost very accurately with the value that's being created at every point kind of along that cycle. So these flexible consumption methods allow you to be able to do that. So when we're looking at the architectures of where we see this deployed, as I said, we see a lot of these going into business edge environments with data intensive applications that are either running critical workloads in a process kind of perspective. So we see these, for instance, in QA and quality assurance environments where we've got products being manufactured or being assayed across a production line, many cameras along that production line that are looking for quality defects, or they might be doing automated screening of things like apples, for instance, is one of the use cases that we've got. Those cameras are all generating high definition video that's needing to be analyzed and stored very close to those environments. These sorts of architectures can fit into that where it's very close to that architecture, being able to take that video and being able to analyze and surface those insights to do real-time quality assurance testing of those kind of environments. We've talked about streaming machine vision data, but there's also where we're using that very close to the edge for telemetry and IoT, so Internet of Things type environments, where we're starting to instrument the world around us, areas like farming, where we're using smart farms to be able to create higher levels of crops, control the environments in which they grow. We're using many, many sensors to detect water, oxygen, CO2 levels, light levels, and using that to tune the environment to the optimum growing conditions for those crops. Those sorts of workloads work really well in this type of environment as well. And often what we find, though, is that those environments, while they're operating on the edge, they're also moving data back into the core to drive some of those long-term machine learning algorithms that help us to gain additional insight and additional value out of that kind of over time. So these environments are very easily connected to cloud architectures. We use either native VMware replication or native PowerStore replication to be able to replicate it into the cloud. If you need a second version of the data close to those cloud resources that are doing that analysis for you on a night-to-night basis, we can connect directly into VMC and AWS type workloads where those VMware environments can be natively migrated backwards and forwards, or we can leverage some of the data replication to be able to do what's called near cloud architectures, where the data is replicated into a repository that can then be accessed from Azure, GCP, or AWS native environments to be able to draw from that data, do the analytics, and drive that back. We've seen a lot of customers leveraging Google GCP with their native TensorFlow capability for this type of application, and that native integration with PowerStore allows that to happen really seamlessly and easily to be able to build that. There are also a number of automated DR and business continuity workloads that can be run in this environment where you can keep a copy of your data close to the cloud, and if there is an issue with the core data center environment, it can very easily be spooled up and run and return those kind of services back into production very quickly and easily. There's a range of capability that you can use there. So that's PowerStore. That's the newest member of our storage portfolio. Again, extremely flexible and adaptable, intelligent with programmability and autonomous capability built into it, so it automatically tunes itself for your environment, and built to be data-centric. So for those customers that are undergoing that data transformation of their workload, this is really a core platform that they're using to be able to drive that. So thank you for your time today. We've got plenty of time for questions. So if you've got any questions that you'd like to answer, please let us know. We are also doing a prize draw. So later on today, for everyone that's attended, we'll be doing a draw to give away an Alienware gaming handset. These are awesome piece of technology, and especially in this environment where we're often working from home, these headsets are really paying for themselves. So good luck, and thank you for attending today. And if anyone has any questions, I'm more than happy to answer them now. You can either use the Q&A or the chat function, or you can just unmute your line and go for it.
Hi, Aaron. Bruce Colstick here. I'm seeing no questions currently coming up on the Q&A. Can you hear me okay?
Yes, I can. How are you doing, Bruce?
Good, thanks. Thanks for that, Aaron. Fantastic overview there. Maybe I could kickstart some of the questions here. The Dell Technology Cloud Platform is obviously very strategic to Dell Technologies. And yes. Perhaps you could elaborate more around how PowerStore and the rest of the categories, Dell Technologies categories, weave their way into that BCF, the VMware Cloud Foundation, and VMware Cloud Story.
Yeah, exactly. So VMware Cloud Foundations is the fundamental software-defined layer that takes all of this infrastructure and creates a set of controllable and programmable and autonomous resource pools that we can kind of consume from. And the Dell Tech Cloud platform really leverages that VCS capability to deliver compute, storage, and network as consumable resource pools with a consumable infrastructure architecture that sits underneath that. It has native connectivity into that multi-cloud capability, because as we were talking, we're finding customers need a range of capability to meet their business needs, both at the edge and their own data centers in the core and consuming from a number of partner clouds. We're seeing that customers are reaching out into like AWS for a developer-centric cloud, GCP for a data analytics-centric cloud, and Azure for more business process workflow-centric cloud, and consuming pieces of those as and when they need to. And the Dell Tech Cloud platform provides a way of joining all of those together to provide a unified method of both operating that multi-cloud environment as well as monitoring and providing those services back to the business, having the confidence to be able to connect into those as and where they kind of need to be. So this is a key part of that. You'll see over time that PowerStore will become integrated into some of our converged infrastructure offerings, and it's already kind of part of that kind of workflow landscape, if you like, in terms of sitting alongside of VxRail for data-centric workloads, as well as being able to integrate for workload-centric ones. So yeah, so key element of that Dell Tech Cloud portfolio.
Thanks for that, Aaron. Still quiet on the question front here, so if I may pose another one. So PowerStore is the mid-market offering, the latest innovation in the mid-market around structured data. And very recently, I know Dell Technologies have released their PowerScale offering. Is that something you can touch upon?
Yeah, absolutely. So as you said, so PowerStore is designed to be the mid-range kind of, it's mostly towards sort of block, but it does have containerized workloads. It does vVols. It also does NFS and CIFS. So it's more dedicated towards real-time unstructured offerings as well as real-time kind of block offerings. PowerScale is designed towards our unstructured data stores that are designed for large, growing, unstructured data stores that are often the target for what we call data lakes or large kind of repositories that kind of grow over time. So they're both very complementary. They work very well together. We do have a unified data replication capability to be able to migrate data to and from. And in fact, that was one of the key design points for PowerStore when it was being designed, was that it had to be very, very simple and efficient to be able to connect to and replicate data between all of the elements of the kind of portfolio. So very complementary to each other. Often PowerStore can deal with kind of smaller unstructured workloads or unstructured workloads that require kind of a real-time element. PowerScale is where you're starting to look at more hierarchical. The other thing to remember is that PowerStore is NVMe only, whereas PowerScale has a range of core storage options built into it. So everything from extremely high performance right the way through to very deep kind of archive type storage capabilities. Well, I think we're at the end of our time now. Thanks, Bruce. If no one else has any questions, we might as well wrap it up there, I think. Thank you so much for your time today for attending. And as I mentioned, we'll be making that prize draw later on today, and we'll be letting the winners know.
Thanks for your time, Aaron.
Thanks, everyone. Take care.